Kaiten were manned torpedoes and suicide craft, used by the Imperial Japanese Navy in the final stages of World War II history. In recognition of the unfavorable progress of the war, towards the end of 1943 the Japanese High Command considered suggestions for various suicide craft. These were initially rejected, but later deemed necessary. Various suicide mission vehicles were developed in the Japanese Special Attack Units. For the Navy, this meant kamikaze planes, Shinyo suicide boats, Kaiten submarines, and Fukuyu suicide divers are human mines. The kamikazes were somewhat successful, and the second most successful were the Kaitens. Research on the first Kaiten began in February 1944, followed on the 25th of July of the same year by the first prototype. By the 1st of August, an order for 100 units had been placed. Development. The very first Kaiten was nothing much more than a Type 93 torpedo engine compartment attached to a cylinder that would become the pilot's compartment, with trimming ballast in place of the warhead and other electronics and hydraulics. The torpedo's pneumatic gyroscope was replaced by an electric model, and controls were linked up to give the pilot full control of the weapon. The original designers and testers of this new weapon were Lieutenant Hiroshi Karikai and Lieutenant Sekio Nishina. They were both to die at the controls of Kaitens, Lieutenant Karikai in a very early training prototype. In total 6 models of Kaiten were designed, types 1, 2, 4, 5 and 6 being based on the Type 93 torpedo. The Type 10 was the only model based on the Type 92 torpedo. Types 2, 4, 5, 6 and 10 were only manufactured as prototypes and never used in combat. Early designs allowed the pilot to escape after the final acceleration toward the target. There is no record of any pilot attempting to escape or intending to do so, and this provision was dropped from later Kaitens, so that, once inside, the pilot could not unlock the hatches. The Kaiten was fitted with a self-destruct control, intended for use if an attack failed or the impact fuse failed. Pilots. The island of Otsushima in the inland sea was used as a training site. It was equipped with cranes, torpedo testing pits and launch ramps, and had a large shallow bay for test running and firing. The Kaiten Memorial Museum is now situated there. Kaiten pilots were all men aged between 17 and 28. Initial training consisted of sailing fast surface boats by periscope and instrument readings alone. When a pilot had advanced past this basic training, he would begin training on Kaitens. Training craft were fitted with a dummy warhead that contained telemetry equipment and an emergency blowing tank that could return the craft to the surface should the trainee dive to a dangerous depth. Kaiten training started with basic circular runs to and from a fixed landmark to reduce speed. The training advanced to faster and more hazardous runs around rocks and through channels in deeper waters. The more difficult runs required the pilot to surface and check the periscope repeatedly, and also required conscientious adjusting of trim tank levels because of the reducing weight as oxygen was used up. When the instructors were confident of the pilot's abilities, he would be advanced to training in open waters against target ships. Training at this level was often done at full attack speed and at night or in twilight. The final phase of training would be a submarine launch and more open water attack runs on target ships. Training was dangerous, and 15 men died in accidents, the most common being from collision with the target vessel. vessel. Although the warheads were only dummies, the impact at ramming speed was enough to not only cripple the Kaiten but also severely injure the pilot. In action, the Kaiten was always operated by one man, but the larger training models could carry 2 or even 4. Kaiten pilots who were leaving for the final missions would leave testaments and messages behind for their loved ones. Deployment. Kaitens were designed to be launched from the deck of a submarine, a surface ship, or from coastal installations as a coastal defense weapon. The Kurosaki Army was equipped to launch Kaitens and took part in sea launch trials of Type 1S. In addition, several destroyers of the Matsu class were also adapted to launch the weapon. In practice, only the Type 1 craft, using the submarine delivery method, were ever used in combat. Specially equipped submarines carried 2 to 6 Kaiten, depending on their class. The Kaitens were lashed to the host vessel on wooden blocks with a narrow access tube connecting the submarine to the lower hatch of the Kaiten. This allowed the Kaiten crew to enter from the host submarine while submerged. Kaitens had a very limited diving depth, which in turn limited the diving depth of the host submarine. This is one of several factors blamed for the very poor survival rate of submarines using them. 8 submarines being lost for the sinking of only 2 enemy ships and damage to several others. Once the target was acquired and the host submarine was within range, the pilot was briefed. The Kaiten starting air bottles were charged and the cockpit was ventilated. The pilot then entered the vessel. The gyroscope was programmed with the correct bearing and depth and the pilot was given his final briefing. The Kaiten separated from the host submarine and headed at speed in the direction fed into the gyroscope. Once within final attack range, the Kaiten would surface and the pilot would check his range and bearing via periscope and make any adjustments necessary. He would then submerge to a suitable depth, arm the warhead and proceed on his final attack run. If he missed, he could make adjustments and try again. If the mission failed, he would detonate his vessel as a last resort. Types. Of the 6 different type classes created, only 4 were ever significant enough to be noted by the American technical missions to post-war Japan. Only the Type 1, a one-man model with a 1,550 kilograms warhead, was used operationally. Over 300 were built, more than 100 of which were sent on suicide missions. General arrangement. The Type 93 torpedo formed the majority of this model of Kaiten, with the only alterations being the warhead yield being increased from 490 kilograms and the control planes enlarged and altered to allow both gyroscope and pilot control. Between the torpedo warhead and the engine section is the torpedo compressed air flask, 6 steering air bottles and the forward trim tank, followed by the control area and the pilot's seat. In later models, the 5.5L tetrachloromethane starting air bottle is located in the cockpit and a further smaller trimming tank is supplied for use. At initial launch, the engine section is slotted in above the aft trim tank with the joint protected by a sheet metal cowl. The pilot's compartment was entered from below through the lower hatch, which was mated to the host submarine. There was a small hand-operated periscope with a vertical range of about 70 centimeters. Controls to arm and detonate the weapon if the attack failed, and steering, velocity and depth controls. Batteries to power the 20,000 revolutions per minute gyroscope were located under the pilot's seat. The air was filtered by sodium peroxide stored in the pilot's compartment. The Type 6 Kaiten was a Type 1 with a modified forward air tank. Performance. After initial trials in water, it was decided to have a maximum surface cruising speed and, for technical reasons, a minimum running speed at any depth of 9.5 km per hour and a submerged running trim of 1 to 3 degrees nose down. During development and use, several problems were encountered. The most pressing being major water leaks into the pilot's chamber during transport and deep diving, and explosions caused by ingress of water into the torpedo engine. These were never fully eliminated during the weapon's active service. Specifications: total weight 8.3 t, length 14.75 meters, diameter 1 meter, warhead 1,550 kilograms. Detonation mechanism: contact manual electric fuse. Engine type 93 torpedo engine. Wet heated double-action reciprocating two-cylinder 410 kilowatts. Propellant: kerosene and oxygen. Maximum range 78 kilometers. Cruising speed 22 kilometers per hour. Maximum speed 56 kilometers per hour. Maximum operating depth 80 meters. Number built: approx. 330 produced. Type 2 in late 1944. Type 2 prototypes were tested in dry dock and in controlled submerged conditions. However, they never met a standard satisfactory for open water running. General arrangement: the Type 2 was fueled by diesel fuel oxidized by the product of the reaction between hydrogen peroxide and hydrazine hydrate, catalyzed by potassium cuprocyanide. Water was also used as a diluent in the combustion cycle. The engine was a custom design specifically created to satisfy the requirements of the Kaiten. It was of a U8 configuration and was in the aft compartment of the vessel. This compartment was open to the sea, with seawater used as coolant. The complete operation of the engine had to be simple for a pilot who was already under immense stress, so it was designed to be controlled by a single lever. The general construction of the Type 2 is substantially different than that of the Type 1. In the forward part of the vessel is the warhead, followed by the fuel, trimming and two steering air tanks. The forward part of the midsection is occupied by the 2600 L hydrogen peroxide chamber. This cylindrical tank required a complicated construction of welding 5 ribs evenly spaced around the circumference, then coating the inside of the tank with tin, then asphalt, and finally with a thick tin plating. Construction of each tank took on average 2 weeks, and the skill required was very high. Behind the peroxide chamber is the pilot's compartment. This is much more complex with more controls than that of the Type 1. From fore to aft controls available to the pilot are depth control gear, trim tank controls, electric switches, gyroscope, rudder control, engine control lever, gauges for various applications, warhead safety gear, engine starter, fuel flow control, and lights with the respective switches. In the aft quarter of the vessel are found the battery for the gyroscope and other electrics, the aft trim tanks, and 2 hydrazine hydrate containers. These containers are made of steel lined with a rubber bag to prevent seawater and the hydrazine hydrate from coming into contact with each other. Immediately behind these tanks is an auxiliary water tank, then the engine compartment. The engine compartment is always completely filled with seawater, so it only has mechanical components. Immediately after the midsection is the generator, the engine, the reduction gears, and finally the propeller and control planes. Performance: the Type 2 had several improvements over the Type 1. It could stay relatively reliably on course with no pilot input and could withstand depths twice as deep as those of the Type 1. Many problems were encountered in the design and engineering of the Type 2, mostly relating to the engine. In initial tests, water pressure caused deformation and seizing of the engine. Although strengthening was added, the problem was never fully resolved. Once the engine was installed in a prototype Type 2, it was unable to reach the required power rating, and this, along with the complexity of the manufacturing process of the Type 2 itself, led to the abandonment of the project. Specifications: total weight 18.37 t, length 16.5 meters, diameter 1.35 meters, warhead 1,500 kilograms. Detonation mechanism: contact manual electric fuse, engine 4.3 Lu-8 engine, wet heater 1110 kilowatts, propellant diesel, hydrogen peroxide, hydrazine hydrate and sea water. Maximum range 83 kilometers. Maximum speed 75 kilometers per hour. Maximum operating depth 100 meters. Number built 1 prototype. Type 4 in early 1945, concerned with the slow pace of development and the unreliability of the supply of hydrogen peroxide. The Japanese Admiralty decided to pursue another line of Kaiten development. Engineers responsible for Kaiten development were opposed to any new work and wished to continue their efforts on development and production of the Type 1. In all, about 50 Type 4 prototypes were made, however they never went into full-scale production and were ultimately abandoned. General arrangement: the Type 4 was an attempt to modify the Kaiten Type 2, to be fueled by the same kerosene and oxygen combination as the Type 93, Model 3 torpedo. The dimensions, equipment and engine were all identical to the Type 2, although the arrangement differed in several key areas. The warhead is identical to the Type 2, although some later models had an access cover at the aft end of the warhead. The forward end of the forward section contains the air vessels. There are 4 in this section. 1 Type 93 torpedo air vessel flanked either side by 2 small trim tanks on the keel and 3 smaller vessels directly above it. The vessels are held in place simply with wood packing. The smaller air vessels are a proprietary design that took some heavy research to perfect. They are sealed by the pressure of the gas. As the pressure rises, a slackly threaded cap presses up against a sealing ring which is screwed down with another cap, thus making an airtight seal. Directly after the air vessels is the fuel tank, which is ringed by the main forward trim tanks. The fuel tank is lightly constructed and contains baffles to prevent sloshing. Just behind this are the 4 steering air bottles. The pilot's space is identical to that of the Type 2. Immediately behind the pilot are 3 more of the smaller oxygen cylinders. However, in some models these are omitted and chairs are placed for training purposes. Between the bulkheads joining this section with the engine section are 2 Type 93 generators, feeding the same Type 6 engine as in the Type 2 Kaiten. The Type 5 Kaiten was a Type 4 with a modified forward air vessels. Performance: the first unmanned test runs of the Type 4 at cruising speed were made in early 1945, and it was noted that oxygen efficiency was very low. The same problem occurred in the first test run with a pilot, with sensor readings indicating a large percentage of unburned oxygen in the exhaust gases. The weapon made little progress in development and never exceeded a speed of 40 km per hour in open sea trials. This, combined with untraceable leaks in the engine and the consequent inefficiency of the propulsion system, led to this design being filed as a failure and its eventual abandonment. The fact that by now the Kaiten Type 1 was in mass production was also a factor in the cancellation of the Type 4. Specifications: total weight 18.17 t, length 16.5 meters, diameter 1.35 meters, warhead 1,800 kilograms. Detonation mechanism: contact manual electric fuse, engine 4.3 Lu-8 engine, wet heater 900 kilowatts, propellant kerosene and oxygen. Maximum range 38 kilometers. Maximum speed 37 kilometers per hour. Maximum operating depth 100 meters. Number built. Approx. 50 produced. Type 10. The abandonment of the Types 2, 4 and their intermediaries. Development of higher capacity batteries. Abundance of Type 92 torpedoes and the ever-increasing urgency to be able to defend the Japanese mainland led to a change of methodology for the Kaiten design teams. The Type 10 is the result. It is essentially a Type 92 electric torpedo with a pilot chamber in between the warhead and drive unit. Over 500 units were ordered to be produced between August and October 1945. However, only around 6 were ever completed. General arrangement. The Type 10 is significantly smaller than the Type 1 and consequently has a much smaller warhead of 300 kilograms. The forward section of the weapon contains the warhead and the manual electric fuse, but no contact detonator unlike other Kaiten types. The midsection contains the first set of Type 92 batteries as well as a steering air bottle strapped to the underneath of the weapon. The pilot's compartment contains firing, starting and gyroscope starting switches as well as a fixed periscope that could only be rotated but not raised to load, the rudder control, trim gauge and a sodium peroxide tin for air purification. The latter part of the weapon contained the remainder of the batteries and a small external steering air bottle. The control planes are identical to the Type 92 torpedoes other than having a manually operated rudder fitted. Unlike all previous Kaitens, the Type 10 only had an upper hatch, so could not be entered from within a Ho submarine. This reflects the design and operation purpose of the weapon as a land-launched coastal defense weapon. Performance. On paper, this model had several advantages over the previous types. Firstly, it was very simple to construct and maintain. Because it had no pilot controls other than to start and steer, it was not complicated to train pilots to use it. It was powered by electricity and consequently had no issue of weight reduction as the fuel was used up, a problem that had caused headaches for test pilots and combat pilots of all previous models. Unlike other models, the engine of the Type 10 could be stopped and even reversed, although this would be of little practical value in a combat situation. Finally, it was very light and small, so it was easily transported to different bases of operation should the need arise. In practice, however, the Type 10 proved to be troublesome. Water leaks into the battery compartments and pilot's compartment were commonly reported by test pilots. It was also very cramped and uncomfortable for the pilot. The war ended before development could really iron out these problems, so the type never went into mass production. Deployment plans. The Type 10 was designed and intended as a coastal defense weapon to counter the expected invasion of the Japanese mainland by Allied troops. On the 16th of July 1945, the Imperial Japanese Naval Command ordered the construction of over 500 Type 10s to be stationed and readied for launch from several existing and new Kaiten bases. Details available in the deployment section above. Specifications: total weight 3t, length 9.0 meters, diameter 0.70 meters, warhead 300 kilograms. Detonation mechanism: manual electric fuse, engine electric motor 6 kilowatts, propellant 112 battery cells producing 54 volts at 120 a maximum range 3.5 kilometers, maximum speed 13 kilometers per hour. Maximum operating depth 20 meters. Number built 1 prototype and 2 or 6 produced.